Lesson 6 is on identifying pairs of angles, and we'll also do Construction Lab 3, so make sure you have a protractor and a straight edge to do this lab. And let's go ahead and start with some definitions, and we have complementary and supplementary angles. And those, sometimes students get those confused because they're very similar. In complementary angles, we're talking about a pair of angles whose sum is 90 degrees. Supplementary angles, that's a pair of angles whose sum is 180 degrees. So times like that, when you're comparing two things that are pretty similar, both have to deal with a certain quantity dealing with a pair of angles, try to memorize one of them. Complementary is 90. If you can memorize that, then kind of by default you remember that supplementary is the 180. And then adjacent angles, those are a pair of angles that share a vertex and a side. And vertical angles, those are non-adjacent angles formed by two intersecting lines. So let's just think about all these things, and let's just draw a line segment perpendicular to another one, and we'll put a right angle box right there. And let's just draw a ray coming off of that. Now this angle and this angle, those would be considered complementary angles. They're also adjacent angles because they share a common vertex right here. That section right there, that point basically is a common vertex for both of those, and they have a common side, this side right here. Now let's look at supplementary angles. This angle here and then this one from here to here, those would be considered supplementary angles. They would add up to 180 degrees or a straight angle, and those are also adjacent angles as well. Now vertical angles, let's think about those. Let's just draw two intersecting lines. And so those would be non-adjacent angles. So like this one here and this one here. Those are vertical angles. And another way to think of them is opposite angles. I don't know why they use the word vertical because they're not straight up and down from each other, but opposite angles works as well. And this angle here and this one, I'll put a tick mark to represent those two, they actually are congruent. They're equal to each other. We'll talk about that more in a minute, but we would consider that pair as well with a single tick mark on the angle mark. Those two are vertical angles as well, non-adjacent angles formed by two intersecting lines. Now let's go over some theorems, and we'll have 4 theorems here, and then we'll have 4 more during the construction lab. And so we have our definitions. They describe what something is. Those are statements that we've agreed on. Mathematicians around the world all use those definitions to describe things. Now that we know the definitions, the theorems will make more sense to us, and we have theorem 6-1, the congruent complements theorem. And if two angles are complementary to the same angle or to congruent angles, then they are congruent. Now a lot of these theorems are analogous to each other, or they compare to each other. For example, think of theorem 5-7. If two lines are parallel to the same line, they're parallel to one another. And that's kind of the same idea here with theorems 6-1 and 6-2 as well, which says that if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So in other words, if angle 1 is supplementary, I'll just say S for supplementary, to angle 3, and angle 2 is also supplementary to angle 3, then angle 1 will be congruent to angle 2. So an angle can have only one supplement and only one complement as well. Now moving on to theorem 6-3, the linear pair theorem. If two angles form a linear pair, then they are supplementary. Now a linear pair, those are adjacent angles whose non-common sides are opposite rays basically. So opposite rays, let's say if we had an endpoint here, we have a ray going this direction. Opposite of that would be this direction. So that whole angle there would be 180 degrees. Now if we add another ray in there, and let's just call this A, this one B, this one C, and then this vertex here D, angle ADB and angle BDC, they form a linear pair, so they are also supplementary. And then last theorem 6-4 here, vertical angles. Those are congruent. So if two angles are vertical angles, and normally we see that when we have intersecting lines, so like this one and this one, those would be congruent. They are opposite or vertical angles. Let's use Geometer Sketchpad now to understand complementary and supplementary angles a little bit better. And you can see I have these two intersecting line segments here. And notice I have this sum up here, measure of EAC plus measure of CAD equals 180 degrees. And so we can see EAD and then CAD, those two angles. Now watch as I change them. Watch as I change EAD. It's changing, but so is CAD, but look at the sum. It is always 180 degrees because the sum of those two is always 180. They're supplements of each other, so it doesn't matter where I go here, that always stays the same. Now if you have Geometer Sketchpad, I'll show you how I made that diagram there to understand supplementary angles better. And first you need two line segments, so you just use that line segment tool, click and drag to make one, click and drag to make the other one. Then go to your selection arrow and select in a white area of the screen. Then highlight both segments there and go to Construct Intersection. And so now you have that intersection, and then you can go to Display. Actually select the points first, and we'll select these 5 points. Then we'll go to Display, Show Labels, and now we have labels for everything. Now I've unselected those points, and now let's just write down or record some of the measures of angles. Let's do two supplementary angles. Let's do JHI, and so we click on those points there and we go to Measure Angle, and here it is. Measure of JHI 63.86 degrees. Now I'm going to do IHJ, the supplement, or I mean IHF, the supplement to that. So I'll hit Measure Angle again, and there's IHF 116.14 degrees. And now I'm going to add those two together. So I go to Measure, Calculate, and I select JHI, hit the plus sign, select IHF, and we see that the sum of those equals 180 degrees. We hit OK. There it is. And now watch as I move this. We can see how those two angles move, and the sum always stays the same. It's always 180 degrees because that's how supplementary angles work. Doesn't matter what the two angles are, they always add up to 180. Now let's find one more measure, and let's do something with vertical angles just so we can learn one more thing here about Geometer Sketchpad. And so I have those 3 points. We'll say Measure Angle, and we see that's 62.32 degrees. And let me move that up here next to the measure of angle JHI, and we know that those are vertical angles. Here's JHI over here. Here's FHG over here. Now watch as I click and drag. Again, look at those two angles. They always are the same. Doesn't matter where I put that. And that goes along with Theorem 6-4, the vertical angles theorem. If two angles are vertical angles, then they are congruent. They're always the same. So using Geometer Sketchpad helps us understand the meaning of always a little bit better. We can see no matter where we put this, those two angles, they are always the same. No matter what position this is in, we always have similar vertical angles, congruent vertical angle. Okay, let's apply what we've been learning about those different theorems and do some practice problems. Practice problem A, which angle is supplementary to AXY? Well, here's angle AXY right in here. Supplementary would be the one that added up to 180 degrees. So it must be this angle right here. And so we'll call that angle, put the angle symbol there, Y, X, Z. That would be the angle supplementary to AXY. Now which angle is complementary to CXY? Practice problem B. Well, you can see CXY there, and notice that right angle box right there. So that tells us that the angle CXZ is a right angle, and so complementary to CXY must again be angle YXZ. So it's complementary to CXY and supplementary to AXY. Now look at practice problem C. Find the value of X. Well, look at what we have there. We have two supplementary angles. And so think about what we could do there. We know the sum of those two supplementary angles equals 180. So if we want to figure out X, we could just say 3X plus 2X plus 15. That must equal 180 degrees. So this is just a problem to help you think about what supplementary angles are and just to work some basic algebra as well. So You'll see problems like this in your homework and your tests. So 5x plus 15, that equals 180 degrees. And we subtract 15 from both sides, and we'd have 5x is equal to 165. And we divide both sides by 5, and that would cancel out over here. We get x equals 165 over 5. That equals 33. And since those are angles, we'll assume that x has a measure of 33 degrees. And I like to put a box around answers like that after I've worked a problem out. So problems like that, make sure you show your work in a very similar form to what I have. You pretty much need that information that I've shown, because if you do make a mistake, you can go back and tell where your mistake was. And I didn't show the step on subtracting 15 from both sides, but that's a basic algebra rule. Hopefully you remember that rule. You can add or subtract the same thing from both sides of the equal sign. It doesn't change the equation, it just changes the way it looks. Let's move on to problem D now. And in the diagram for problems A and B, identify two pairs of adjacent angles and two linear pairs. So it doesn't matter which two pairs you do here for adjacent or linear pairs. Two adjacent pairs, I'm going to say angle AXB and angle BXC. They have a common side and a common vertex, and we see that middle letter there. Those should be the same, of course. That lets us know that they have a common vertex. And then another pair would be angle BXC and angle CXZ. So those are also adjacent. Two linear pairs, that would be angle AXB and angle BXZ, because those have to add up to 180 degrees. Their non-common sides have to be opposite rays. And let's think of another pair here of a linear pair. We could have angle AXY and angle YXZ. That's also a linear pair. So hopefully now you're pretty familiar with adjacent angles, supplementary angles, complementary angles. Let's look at vertical angles in problem E. Find the values of x and y there. Well, first let's remember that those vertical angles are congruent. So we could say, to start out with, that 4x minus 19 is equal to 2x plus 7. And we can solve this for x. Then once we figure that out, we could figure out y, because it's a supplement to those angles. So let's add a negative 2x to both sides, and we'll get 2x. Actually, let's go ahead and add 19 to both sides while we're at it, and we'll get 2x is equal to 26. X equals 13, and we'll put a degree symbol on that so we know what x is now. Now we can figure out the actual value of that angle. So let's look at the 2x plus 7. 2 times 13 would be 26, plus 7 would be 33 degrees. Now to figure out y, we know that 180 is equal to 33 plus y. So we just subtract 33 from both sides, and we get that y is equal to 147 degrees. So there's our answer. And again, I like to put a box around the answer that just identifies where the answer is. Makes it easier, especially when someone's grading the work. So again, make sure you show work on these types of problems. And hopefully you can see that that problem was easy because we knew the definitions and the rules here, the theorems. We knew the theorem that vertical angles were equal. If we didn't know that, that would make it very difficult to know how to solve for x. But knowing that rule, that makes it very easy, because you've already had algebra. Well, hopefully you have, and so you know how to do algebra. Then after that, also knowing what a supplementary angle is, we knew that, and that made finding what y is very simple. So these problems can be incredibly difficult or incredibly easy depending on whether you memorize your rules. So make sure and take time to know the difference between a supplementary and complementary angle. Know what a vertical angle is. Know that they're congruent. Know those theorems. Okay, well, let's go on to the construction lab now, and let's look at these two theorems, and let's do some constructions based on that. So theorem 6-5 and its converse, theorem 6-6. 6-5 says, if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. And theorem 6-6 is just the converse of that. Well, let's go ahead and figure out how to find a perpendicular bisector, how to make one. And first what we need, of course, is a line segment. So with your straight edge, you'll want to make a line segment, and you can put some dots on the ends there. Then get your compass out and put the point on the point of the compass on the point on the left side, and then stretch the compass out so it's past the halfway point. And you can kind of see me moving back and forth there, and you can tell that I'm past the halfway point. And you'll want to make a mark up above and down below, and then you'll just keep the compass distance the same, then go over to the other point on the right hand side, and keeping that distance the same, you'll intersect that arc that you just made above, and also of course intersect it below. Then you'll take your straight edge and connect those 2 points together, and I didn't connect them exactly perfectly, but that's pretty close. So what we've done there is made a perpendicular bisector, and we can put a dot right there in the middle there to represent that point. That point is equidistant from the endpoints of the segment. Now let's look at theorem 6-7, and its contrapositive, 6-8, says if a point lies on the bisector of an angle, then the point is equidistant from the sides of the angle. And just a historical note here, Euclid, he had propositions is what he called them instead of theorems. He just used a different word. We call them theorems. Same idea though. They have to be proved from the postulates. Properties are also used to prove theorems. But this particular theorem was proposition or theorem number 9 in Euclid's Elements. So for this activity, let's go ahead and make an angle, and then we're going to make a bisector of the angle, a ray that's going to split it right in half. So it doesn't matter what kind of an angle you make, but make one big enough so that you can see what the bisector is going to be. And so here's an angle, and so let's just put a point at that vertex, and then go ahead and spread your compass out, put the point of the compass at that point, and make it maybe halfway or so, maybe a little bit more along that segment, and you'll make an arc that connects both of the rays. So you have that arc there, and now you can just leave the compass the same distance. You can change it if you want to, but it's fine just to leave it the same distance, and you'll have a point here where there's an intersection, a point here where there is an intersection, and we know that those 2 points are equidistant from the vertex. But now you'll take the point of the compass and just make an arc out and to the right, and you'll intersect that arc. Yeah, and then you take the point, put it on the point of the compass, put it on the point above, and draw another arc, and you have those intersected there now. And so take your straight edge, line it up with that intersection and with the vertex, and go ahead and draw, and you should be able to make a line, and you'll see it goes almost right through there, and it splits it right in half. Okay, now look at this point that I'm drawing right now. That is a point that lies on the bisector of the angle, and it could be that point, it could be this point here, but wherever that, just a point on the bisector of the angle, it's equidistant from the sides of the angle. So in other words, this distance from here to here, that line would be the same length as this one right here. Okay, well that's all for lesson 6.